GDDR5, an abbreviation for Double Data Rate Type 5 Synchronous Graphics Random Access Memory, is a modern type of synchronous graphics random access memory with a high bandwidth interface designed for use in graphics cards, game consoles, and high-performance computation. Overview: like its predecessor, GDDR4, GDDR5 is based on DDR3 SGRAM memory, which has double the data lines compared to DDR2 SGRAM, but GDDR5 also has 8-bit wide prefetch buffers similar to GDDR4. GDDR5 SGRAM conforms to the standards which were set out in the GDDR5 specification by the JEDEC. SGRAM is single-ported. However, it can opening two memory pages at once, which simulates the dual-port nature of other VRAM technologies. It uses an 8N prefetch architecture and DDR interface to achieve high-performance operation and can be configured to operate in A32 mode or A16 mode, which is detected during device initialization. The GDDR5 interface transfers two 32-bit wide data words per write clock cycle from the I/O pins. Corresponding to the 8N prefetch, a single write or read access consists of a 256-bit Y2CK clock cycle data transfer at the internal memory core and 8 corresponding 32-bit wide 1/2 WCK clock cycle data transfers at the I/O pins. GDDR5 operates with two different clock types. A differential command clock as a reference for address and command inputs, and a forwarded differential write clock as a reference for data reads and writes, that runs at twice the CK frequency. Being more precise, the GDDR5 SGRAM uses a total of 3 clocks, 2 write clocks associated with 2 bytes and a single command clock. Taking a GDDR5 with 5 bit data rate per pin as an example, the CK clock runs with 1.25 GHz and both WCK clocks are 2.5 GHz. The CREAK and WCKs are phase-aligned during the initialization and training sequence. This alignment allows read and write access with minimum latency. A single 32-bit GDDR5 chip has about 67 signal pins and the rest are power and grounds in the 170 BGA package. Commercial implementation: in 2007, Commander, a spin-off of Infineon, demonstrated and sampled GDDR5, and released a paper about the technologies behind GDDR5. As of May 10, 2008, Commander announced volume production of 512 MB GDDR5 modules rated at 3.6 Gbps, 4.0 Gbps, and 4.5 Gbps. Hynix Semiconductor introduced the industry's first 60 nanometers class 1 GB GDDR5 memory in 2007. It supported a bandwidth of 20 GB per second on a 32-bit bus, which enables memory configurations of 1 GB at 160 GB per second with only 8 circuits on a 256-bit bus. The following year, in 2008, Hynix bested this technology with its 50 nanometers class 1 GB GDDR5 memory. Hynix 40 nanometers class 2 GB GDDR5 was released in 2010. It operates at 7 GHz effective clock speed and processes up to 28 GB per second. 2 GB GDDR5 memory chips will enable graphics cards with 2 GB or more of onboard memory with 224 GB per second or higher peak bandwidth. 4 GB density GDDR5 modules first starting becoming available in the third quarter of 2013. Initially released by Hynix, Micron Technology quickly followed up with their implementation releasing in 2014. Modules from both Micron and Hynix, of both the 2 GB and 4 GB densities, range in bit rate up to 7 Gbps. On June 25, 2008, AMD became the first company to ship products using GDDR5 memory with its Radeon HD 4870 video card series, incorporating Commander's 512 MB memory modules at 3.6 Gbps bandwidth. On February 20, 2013, it was announced that the PlayStation 4 will use 4 GB 512 MB GDDR5 memory chips for 8 GB of GDDR5 at 176 Gbps as combined system and graphics RAM for use with its AMD-powered system on a chip comprising 8 Jaguar cores, 1152 GCN shader processors and AMD True Audio. See also, List of device bandwidths, references. External links, Introduction to GDDR5 SGRAM, by Elpida, Making Accurate Measurements on GDDR5 Memory Systems, GDDR5 Pinout and Description.